So welcome everyone to phase 2 of the Curator program. We hope you had a fantastic phase 1 and enjoyed it as much as we did. I can say from myself and the Graph team, we are just so humbled, shocked, impressed with the interest that you guys have had in both learning about the Graph and also elevating Everest. Just a few stats to share. So Everest currently has over 1,600 projects. It's incredible. We're really looking at the entire Web3 ecosystem, and we hope you continue to add to it. Ethereum-based and other blockchains as well. In terms of submissions for phase 1, we had 1,400, yeah. We had over 400 mission control curator issues and over 37 PRs. We also had several bots made, which is really awesome. So one was for Telegram and for Discord. We had hundreds of translations. Really awesome to see how global our community is, in particular in Russian and Japanese. We've also had hundreds of thousands of memes made. The Graph team, every single day we're sharing between our team these incredible memes of our team, of how you guys are interpreting the vision, and it's so exciting to see the community growing. We've also had a few Discord MVPs we want to shout out. So King Z, Slim Chance, Fubi, and Trader Payne. You guys have been incredible. Keep it up, and we look forward to hearing more from you in phase 2. So now I'll pass it off to Yaniv, our founder, to speak more about evaluating subgraphs.
Thanks, Eva. So I actually want to start just with a quick recap of phase 1. So I personally went through everybody's issues that you created in the Everest repo and the mission control curator repo. And it was really amazing to see just how much people really understood the vision. And, hopefully you've had a chance now to, create a project on Everest, browse, maybe do some challenges. And, I think we're at a really remarkable place now with, these 1,600 projects. So, really great starting point. So appreciate everyone who, challenged projects and were active. I think it's pretty clear that there are some things that have been, rough around the edges. And so there were some really great suggestions in the issues on GitHub for improvements to make. So things like, I know that the challenge and claiming flows right now are, a little bit difficult, and it would be much better if you could get like a notification, for example, if you're the project owner and somebody wants to claim it, you really should get like a push notification and be able to take action right away. So, clearly that would be an improvement. There were some really great discussions about how reputation is assessed. Right now, we calculate reputation just based on how long you've been on the registry, but there were some really great ideas about other ways that you could do reputation. And generally, there were just, a lot of really great suggestions. So, I hope people, keep thinking about how to improve something like this and recognize that, this is a pretty simple flow that we're doing here, just allowing people to create projects and challenge projects and really, maintain a quality registry. And, if we continue to iterate on this and make these types of improvements, then I think we'll have a really great template that we can use for lots and lots of different registries. I could see many thousands of these types of registries, out in the wild, built on Ethereum and on different layer 2s and on different blockchains. And as curators, on the last call, we kind of talked about, the approach of really starting with the data model and thinking about like, what is the data that we want to express and kind of working out from there. So, people had a lot of ideas of, more data that they would want to have linked to these projects. So for example, being able to see the assets that a project has created, or maybe, the DAOs associated with a project, or the team members, or, it really just goes on and on. And so if you start with the data model in mind, then you can think about where is this data going to come from? And maybe there's an existing protocol that you want to get the data from. And so in that case, all you need to do is create a subgraph to index that data and bring it onto the graph. maybe it's, simple data, like these Everest projects, and the right solution is a registry, just like this, a kind of curation DApp, just a registry that people can vote on. But something like projects, we're kind of bootstrapping this kind of social consensus over who should own the project listing. And then once somebody owns a project listing, maybe that gives them rights to create data without having other people challenge it, because they're basically like the source of truth for that project. So, if I own, if we hop into governance and I own, Colony, maybe I'm the source of truth then for who the teammates, right, the team members of the Colony project are. And so that's not subject to challenge. So, these types of rules are really going to depend based on the domain. And so I think, these experiences will be very customized. And sometimes the solution to managing data in a decentralized way is going to be a registry, and sometimes it might be like a really complex protocol. And the answer is, first we've got to build a protocol on a blockchain like Ethereum, and then you can build the subgraph behind it. But I think it's an interesting lens to kind of start with the data model. What data do we want to have on the graph, curated in a decentralized way, and then from there work through how do we get the data there. And so at the top of the stack is the subgraphs, and part of the role of curators is bringing more and more valuable data onto the graph and organizing that data. We've been working on this now for a while, and we've experimented with different ways of incentivizing people to build subgraphs. So we've participated in a lot of hackathons, things like the ETH Global events, and then we've also hosted our own hackathons. So this is one that we did last December called Indexing the New Economy. And we had prizes for people to build subgraphs. And for this one, we decided to have specific subgraphs that we wanted to have built for protocols that were built on Ethereum. And we focused this one on DeFi protocols. And these were ones where, we didn't have good subgraphs yet. And I think this was a really fun event. We had a lot of participation. We got some great subgraphs built. And part of what we did here was come up with a list of requirements so that developers that wanted to build these subgraphs could get a sense for the complexity and what it was that we were looking for out of these subgraphs. So here you can see our best attempt to estimate the prizes that would be worth paying out for developers to build these subgraphs. And this is something that we did kind of, in a centralized way, you could say, where we single-handedly chose, hey, these would be subgraphs that are valuable. Here's roughly how much work we think it would be to build these subgraphs. Now going into the future, this is the kind of thing that we would love to see, done in a decentralized way, where, curators, are closest to the ground. They're involved with different projects and protocols, and you would probably be in the best position to know which subgraphs would be valuable to the community. And so, there's a skill here in being able to identify subgraphs that need to be built, be able to scope how difficult would it be to build this type of subgraph. And how valuable would it be to the community? And then similarly, a job of a curator is to evaluate existing subgraphs. So maybe there are subgraphs that are already deployed, now on the hosted service, in the future on the network, and maybe there's really important data that's missing, or maybe some data is inaccurate. So the ability to dive in, assess the quality of subgraphs, see what improvements need to be made, and then ultimately organize resources, to deploy, the protocol treasury to fund the development of new subgraphs. is going to be a really key component of being a curator. So we're going to have Dave go through and give you more of starting with an introduction of what subgraphs are more in depth. I know we've done this at a high level, but now we're actually going to dive in and then explain how to go about evaluating different subgraphs.
Awesome. Thanks, Yaniv. I'm just going to share my screen here. So what I'm going to go over is, kind of like subgraphs that already exist in the network. And I'm going to go a little bit in depth on how they work and how you can actually evaluate them, how complex they are, kind of looking at blockchain data and determining what subgraphs could be built in the future, and just going into all the details of what it's like to be a curator and also what it's like to be a subgraph developer, or else evaluate subgraph developers who have created subgraphs. And a really good place to start is just the Explorer. I'm sure you guys have seen this before. It's it's right on our website, and it's just, this is where you can see a lot of the featured subgraphs that are very popular in the community, and you may have heard of a lot of these projects. And it's a really good idea to just like go into these and kind of look at them and check out what's going on. And Uniswap's actually one that we're going to look at a little bit later. But the first place that I would like to start is just like a primer with the documentation. So the documentation on our website is very like all encompassing and will teach you everything you need to know about the graph. But for this specific tutorial that I'm giving here, I'm just going to really go over like the high level stuff about defining what a subgraph is. So there's always three parts of a subgraph that I really think are like the main key components when you want to describe it at a high level. And the first one is the subgraph manifest. And the way that I always think about the subgraph manifest is it's like the instruction book or like the instruction manual for the graph node and for the graph network to know what data to actually index from a blockchain or from Ethereum, right? So this is, this is a very simple file right here. It's just these lines right here. It's very easy to read, and it's very straightforward. And what I want to point out is some of these really key components here is like, so this line right here is telling us, look at the Ethereum mainnet for some blockchain data that we want to look at. And then we start drilling down even more. And it's like, go to this address on the Ethereum mainnet, and this is the one that we're concerned about. This is the one that we care about for this subgraph. And then when you drill it down even more, you start to pay attention to the specific like events that are emitted by that contract, or even like functions that are called on that contract. So what the whole point of the manifest is it's just, we have all this blockchain data out there. It's all kind of not organized very well, and it's all just like on Ethereum. And what we're telling the graph node to do is focus in on this specific network, on this specific contract, on these specific events that happen. So a subgraph manifest can actually contain a lot of different contracts. It doesn't just have to be one. And that's basically like really the starting point for the subgraph. It's the instruction manual for the graph node. And it's kind of where you would start as a subgraph developer for what you would want to build for a subgraph. And from this is very high level. You can't really tell how complex a subgraph is going to be just from looking at this, but you can get an idea that, you're going to be looking at the Uniswap smart contracts. And in this case, it's this contract called Gravity. But it's kind of like a high level kind of like introduction telling you what this subgraph is going to be about. The next really big part of a subgraph is the GraphQL schema. So if you don't know about GraphQL, highly recommend like looking it up and reading our docs and reading their own documentation. It's a really good querying language that really fits itself well to Web3, and it's the reason why we chose it to be part of like graph nodes and part of the graph network and how it's all organized and like part of the tech stack. And really briefly, not to get too into details on the code, but this is an entity in a GraphQL schema that would be in a subgraph, right? So what this is, it's just a data object, and it's actually really easy to read. It's this thing called Gravatar, but it has an owner and a display name and an image. and a Boolean of what, if it's true or false, if it's been accepted or not. So anybody can kind of read this and understand what's going on. And we'll look at a much larger schema very soon, but basically what the schema is, compare it to the manifest, which is the instruction book, what to look at on the blockchain. And then the GraphQL schema for a subgraph is basically what the subgraph developer's idea is for what they want their data to be kind of like presented in or organized in a way. So like all the data right now is on Ethereum and it's unorganized. We've told the graph node to get that specific data, and now the subgraph developer is organizing it in the certain kind of like the schema that they want with the entities, and it's going to basically organize the database in like that's built into the subgraph into that order, and it allows this data to be easily readable from people from the outside. Because the whole idea of a subgraph is to be like this API that people can query, and it's an open API and it's all open data. So you want your subgraph to be readable by other people and usable by a lot of people. So that's kind of the idea about the subgraph or the GraphQL schema. It's really the shape of what the subgraph developer wants their subgraph to be. And it's definitely kind of the highest level thing that you can look at and determine the complexity of a subgraph. It's like the biggest signal kind of indicator to me, you know, because you don't even really have to know how to write code to be able to look at a schema and understand what's going on, because it should be human readable, and because it's this open API that other people are supposed to be able to come to and be able to tie into. So, you know, if you're a curator and you're trying to determine the complexity and the usefulness of a subgraph, it's definitely the GraphQL schema that is what you would want to look at. And the last like really big part are mappings. And I won't get into too much detail on these today. It is a little bit more complex in the code kind of that you have to understand. It's all written in TypeScript. And so if you know TypeScript, or even if you know JavaScript, you can definitely like read this and understand what's going on. And if you read the mappings, it will be able to tell you how complex a subgraph is and what it's doing. But at the end of the day, like what the mappings are is it's basically like the piping between the subgraph manifest and the GraphQL schema. And it's saying like the subgraph manifest gives you the raw data off of Ethereum. And then the GraphQL schema is what the subgraph developer wants to be put out in the end and for allowed to people to read that blockchain data. And the mappings are what like kind of translates the data from the blockchain into the subgraph. So there can be a lot of complexity in here, and it's actually very, very like, it's where like kind of all like the heavy lifting and all the heavy work of the subgraph developer goes in. This will take most of their time. But it is useful. If you can read this, basically, if you can read the mappings and also the GraphQL schema, you can really determine what a subgraph does and how complex it's going to be. And so next, what I want to do is I want to really get into the Uniswap subgraph. Just going to refresh this here. So Uniswap subgraph is right here. It's probably one of the most popular subgraphs. It's used a ton. There's so much data that's coming out of Uniswap because it's probably the most popular protocol on Ethereum. And as you can see here on the right side, this is the public, you know, the GraphQL schema. These are all the basically data objects that the subgraph developer decided they wanted, you know, to be available, and they've organized it in a way that makes this subgraph unique. Like this subgraph is, this specific Uniswap subgraph has a lot to do with like data analytics and also like aggregating data, because this is actually the website that gets powered by the Uniswap subgraph. So this is the Uniswap subgraph. This is called, you know, this is the playground on the Explorer, and you can see like, we have a query over here on the right side. We're asking for data about tokens. We're asking for data about the Uniswap factory. And the subgraph actually has all this data. You know, this is blockchain data that has been indexed and organized with the subgraph, and now is very easily queryable and also very fast to query, which is one of the huge improvements that subgraphs give. And it's part of the reason why the graph network exists, it's this big like middleware kind of protocol that allows all this data to be stored and indexed by the graph, and for people to be able to easily query it and actually see what's going on the blockchain. So this app is actually powered by Uniswap, or sorry, by the Uniswap subgraph. And really briefly, I want to also get into how complex the Uniswap subgraph is, and that's basically what I'm going to be breaking down over the next 10 minutes. And for anybody who doesn't know Uniswap, I just want to really quickly show you that like this is basically the Uniswap application, and it's a really simple app. Like the main two functions are adding liquidity, basically providing like tokens for people to be able to trade off of in a pool, and then swapping one token back and forth. So you might swap like ETH between DAI. So this is like, if you look at this application, you realize right away that there's not too much complexity, and it's actually built to be simple, right? So that should give you a hint what the subgraph might look like. And so you go over here to the uniswap.info website, and you realize there's all this, like a ton of this rich data here. And like this whole entire chart was built with a subgraph, and this liquidity chart was built with a subgraph. And then what we have over here, so Uniswap is like a big decentralized exchange, and you can basically exchange any ERC20 token with any other ERC20 token, as well as, like wrapped Ether. And you can see here, like we have this aggregate data of how much volume is actually being transacted on chain. So this data isn't actually stored directly in, the Uniswap smart contracts. This is aggregated data that is created by the subgraph, that the subgraph developer recognizes useful information. Like people really do want to know how much volume Uniswap is creating each day for each token pair. They also want to know the USD price of all the tokens, as well as the price in Ether. And they also want to see like how has Uniswap been growing over the last 3-4 months. All this data is very rich data that was created by the subgraph developer, and was basically, it's what the subgraph does. It's what makes the subgraph very useful and very unique. So now I'm actually going to get a little bit more into the Uniswap subgraph itself. And this is going to be very high level, but I kind of want to go over like how you determine what a subgraph is and how complex it is. So really, really quickly, I just want to open the main Uniswap smart contract code. And here we have like, there's only about 3 files. And in total, these 3 files are about 350 lines of code. So like right away, you saw the front end interface in the application. It was pretty simple. And then you kind of look at the Solidity code. You don't even have to read it, but it is readable if you don't know code. But essentially, you look at this and you're like, okay, this protocol is not that complex. It has a good chance of being a simple subgraph. You can't glean all that information from this, but it's like a good indicator of the fact that the subgraph might not be that complex, it might not be that big. And so, that's the Uniswap smart contract code. I'm not going to go into detail on it here. What I will go into a little bit more detail on is the actual subgraph files we have for it. So here's the subgraph manifest file for Uniswap. And as you can see, like this is, we're on Ethereum mainnet. We're looking at the Uniswap main factory contract. And then we are looking at this specific event. And, to get into a little bit more detail, we have these things called data source templates. And so the Ethereum or the Uniswap factory makes, a pair of tokens that are being traded. It might be Ethereum and like DAI. And then each of these like templates is going to be made for each of those pairs. And then what's happening is like this subgraph is indexing these 5 events on these token pairs that are trading. And this is really the bulk of all the information that we're getting from Ethereum. This is pretty much going to be most of the whole entire subgraph. And then we're going to do a lot of like data analytics with all this and kind of organizing of the data. But this is, if you go to the manifest, it's the instruction book for the graph node, but it also should make very clear like what data we're going to be looking at for the subgraph. And so this is now the GraphQL schema for Uniswap. And if you look at it, it's very human readable. You don't have to know how to code to understand what's going on. You know, we have like a specific token, and you can imagine exactly what that is. We're going to have how many times this token's been traded, the total liquidity that is stored in Uniswap for this token, the trade volume over time, the trade volume in USD. And so you have all this kind of stuff. It's actually pretty easy to read and understand. And you can kind of see, okay, you know, this is probably a Uniswap subgraph, and it's probably doing a lot of data analytics. Just by reading, you know, the names that the Subgraph developer has given to all the entities and the entities fields. And so if you look at some of these, like, this is going to get like a little bit more in detail about looking at a schema, like a GraphQL schema. And if you look at, for example, something like this, it looks pretty basic. And the point I want to get across is, like, sometimes you can have entities that are just static data. And what I mean by that is, you know, a lot of these fields, like right here, are just direct values that are admitted by Ethereum events. And it's actually, whenever you see that, and we're just copying over static data from the blockchain into the subgraph, it's kind of a good signal that it's going to be a pretty simple subgraph, because it's not hard to copy over data. What is hard is to, like, build those charts. So like this chart, very complex to build, took the Subgraph developer a lot of time to get done. But if you look at something like this, a transaction, like this is just a transaction that happened on Ethereum. It's just kind of storing these static values. You know, you could go to Etherscan and see this. If that's all the developer did was the Uniswap transactions, then it's going to be a very simple subgraph. So that's something to note, is like, you know, there's not one Uniswap subgraph. There is a bunch of data on Uniswap, and you can decide what your Uniswap subgraph is going to be. So like this developer, their main goal was for it to be like an analytics subgraph, and that's what it does. So I would actually, what I would say, like this subgraph itself, the complexity is like medium to medium hard. And the reason it's because it's doing all this aggregate data. And if you kind of look at the, you know, if you're reading the if you're reading the schema right here, you see this stuff like pair hour data and pair day data, which I'm not, yeah, pair day data. So what's happening here is, like, the Subgraph developer is taking all of these transactions for every single, you know, trade that happens, and they're adding them up for the specific pair. So this is all aggregate data. Every time, you know, DAI and ETH is exchanged, one of those transactions adds to this value. And then they'll figure out how much has been done in that day. So they take like a 24-hour period, depending on like the timestamp of the blockchain and like the blocks that are being created on Ethereum. And they're aggregating all this data. So all of a sudden you can see the subgraph has just gotten a lot more complex, because we have aggregate data. And not only are we, you know, adding it up to show it in this kind of nice chart or this kind of table right here, it's also, you know, we're building these charts. So that's why I say it's medium hard, this subgraph. You know, the first thing was when I looked at the smart contract code, I kind of thought, you know, 350 lines of solidity, this is not that complex. You know, maybe it's going to be an easy subgraph. But then when you read the schema and you realize the intent of the subgraph developer, you realize they want it to be an analytics subgraph. You realize they're going to have to be doing a lot of aggregation, and it might actually be complex. So very briefly, I want to go over the mappings as well. So like I said, this is kind of the piping between the subgraph manifest and then getting the data to be in the schema that you have. And as you can see, the mappings are a lot of code. Like this one file, you know, 600 lines of code, 200, about 100 there, another 150 there. Like there's over 1,000 lines of code for the subgraph mappings. And the reason is it's because of all that like aggregation data that this subgraph developer is doing. It actually takes a lot of effort to just realize, okay, you know, you have to make sure that every transaction that happens on Uniswap is recorded correctly by you. Because if you have even one error, like if you're adding a value where you're supposed to subtract it, it's going to make the numbers all out of whack. and then you have to like examine the subgraph and figure out what's wrong and why it's wrong. And so really here, there's a lot of details in here. So if you're like a developer and you know JavaScript or TypeScript, you should be able to read, these files and understand what's going on. You also obviously have to understand what Uniswap does. But essentially, yeah, like this is the most complex part of the subgraph. Luckily, because Uniswap is kind of a simple protocol, that's why I would call it like medium hard. And so as somebody who's, I kind of described the last 10 minutes from the perspective of a subgraph developer. So if you're like a curator on the graph network, you're basically, you're going through the graph network and looking at existing subgraphs, and you're trying to determine like which subgraph is very useful and which one you want to maybe signal, some graph tokens to, in order to say like, I think this subgraph is of high value for a lot of people. And so if you look at the Uniswap subgraph, we just explored it, and it says right here, historical data for analytics. You might realize that, like Uniswap is a very big decentralized exchange, and there actually are a lot of tokens that are only traded on Uniswap. And so some of the big websites like CoinGecko and like CoinMarketCap actually tie into Uniswap to get price information. So like price information for Uniswap is very high quality, high sensitive data, because people make trades on that decisions. People actually have money involved on what the prices are if they're hitting the Uniswap API. So as a curator, or else somebody who's like a curator / subgraph developer, you might look at this and say, well, maybe somebody should make a Uniswap subgraph that is just specifically about price feeds. And then that would be a simplified subgraph, it would have less area for errors because it's only doing one thing. And then maybe even like CoinGecko would end up tying into it. And so like if you saw that one come up and you are a curator and you recognize that kind of business scenario where, price data is super important. And that's true for all protocols on Ethereum. Like if you want to look at Compound or other protocols, price is always going to be very valuable because that has to be accurate. So as a curator, you might scroll through the existing subgraphs and say, well, there's this aspect of Compound or Uniswap, that I think could be separated into its own subgraph or created. And I think that'll make a lot of value. And so if you can recognize that, like you don't have to necessarily be a developer, you could just watch for that and see if that subgraph comes up and curate on it. Or if you are a subgraph developer, you could actually build that subgraph yourself, and you would be able to be the first one to curate on that subgraph, and you'd be able to like drive adoption for it. And the beautiful thing about the whole graph network and the whole Web3 movement is all of this is done in an open source manner. And so when you build something like a subgraph, it's for everybody to use. And if you build a really good subgraph, a lot of people will actually use it, and then you'll end up being rewarded for it. So, that's kind of like a breakdown of thinking about it from a curator's perspective. And next, what I want to quickly do is just go over the Everest subgraph as well, because I think a lot of you are familiar with it. Like Yaniv went over this earlier today, and I'm sure a lot of you guys have played around with it and created projects. And so if we look at the Everest code, I want to quickly just open up the Everest smart contract. So the main smart contract itself is about 700 lines of code. And so you might look at it and say, okay, that's kind of, it's longer than Uniswap's was. Maybe it's going to be more complex. But if you also look at Everest, right, it's basically a registry of projects, and it has voting and challenges. And those are kind of the three main functions. So it's also like Uniswap in the sense that it's a very simple application, right? And that's the way that Everest was meant to be built. It was supposed to be simple, and it was supposed to like champion what it's like to be a fully decentralized Web3 application. And so that, like, the dApp itself has about 3 functionalities. You look at the code, it's 750 lines of code. You're saying, okay, like how complex is this subgraph and what does it do exactly? So then we're going to go and look at the actual subgraph code again. And so that's the manifest. We see that it's just focusing, there's a little bit of configuration here, but basically it's just looking at the Everest smart contract for the most part and looking at all the events that are emitted by that smart contract. And if we look at the mappings here, the mappings for Everest are actually a lot shorter. And this is what I was kind of talking about, like that static data, that one-to-one data. Like what I'm doing here is just basically copying over data from Ethereum and putting it into my own schema. My voting entity, my voting object, data object that I made, I'm kind of just copying it over. And the good thing is, like, I wrote the smart contracts for Everest, so I also knew in my head what they were going to look like, and this made it easier for me to actually write the subgraph. It's a little bit different when somebody else developed, like someone else did the Uniswap protocol, right? But if I write the subgraph for it, I have to recognize what the protocol is doing, and I have to kind of study it myself to determine what the mappings are going to do. But anyhow, like this set of mappings, it's about 200 lines, and then there's also like a helper file with 100. But I look at it, and it's not too complex. It's not too long. And then if I look at the actual schema, I realize it's also pretty short. And then you start reading it, right? Even if you didn't really know what Everest was, you read it, and you're like, okay, it's got a description, it's got a website, it's got a Twitter handle. It's like very high level kind of, it's some sort of project or like account that somebody's displaying. We're storing what time it was created at. So you start to get this image in your head. You're like, okay, this isn't too complex. This is just kind of like static web data that somebody's going to be reading. There's not any prices. There's not any like data aggregation. You look at it and you see, challenges and voting. It's a little bit more complex, and you say, okay, what is a challenge? Maybe, I don't know. Let's look at it. Scroll down. What's a category? You read it and you're okay. Yeah. Once again, it's kind of like a static kind of piece of web text that somebody's going to be reading and trying to understand. So you read that over, you say, okay, I understand that. And then you read a challenge and you realize, okay, it's something that people are voting on, and then project that is being challenged, owner of the challenge, which is a project, and you start to get this kind of idea in your head what it is. And you're like, okay, there's these things called projects. People vote on them. You can challenge a project. And that's pretty and all these projects fit into categories. So you look at that and you kind of think maybe you can, I don't know how long it would take somebody to figure out what the Everest subgraph is doing, but it definitely would be a lot shorter of an amount of time than the Uniswap one. So that's why I would say Everest is actually for complexity, Everest is an easy subgraph for somebody from the outside to come and look at and kind of determine how complex it is and what data it's providing to the community, and then also determining if it's worth it to be a curator and to signal on that subgraph. And there were some really good examples too from just the phase 1 missions. This one person, Zoltar7, came in and pointed out, they even said, I'm kind of new to writing subgraphs, but this looked a little bit weird to me. And they pointed out that this part of the code looked a little bit different. And then they suggested that, maybe it should be this with the derived from property. And then, what I realized is basically there wasn't an error in the subgraph, but what Zoltar pointed out was that what I ended up realizing is the way that he was doing it was actually more efficient. And we don't have to get into details about that. You can go read this issue. It's in the mission control curator issues on GitHub. But basically I realized, I was like, yeah, that's a good point. This is actually a better way to do it. And I'm going to update that later this week. So that's the great thing about all this subgraph kind of curators and open APIs is, this guy Zoltar7 came in and just was able to contribute right away and said even they weren't, an experienced subgraph developer or anything. So that's really cool. it goes to show that a lot of people are able to like read these subgraphs and figure out if they're useful and like what kind of data they're providing. And there was also another person who provided all these subcategories, you know, suggestions to basically add subcategories to the categories that exist here. And a lot of them are actually really good and well thought out. And it's the same thing, like you don't have to be a developer to contribute to, you know, these subgraphs, because, you know, you obviously, they had to understand what Everest is doing. And, you know, all you have to understand is categories. And now they provided feedback that is actually really good. And like, we should probably add in a lot of these suggestions to Everest for sure. It just goes to show that, like, you know, depending on what type of subgraph we're looking at, you know, different people can contribute in different ways, and a lot of people can. And the last one that I really wanted to go over briefly is just compound. We're not going to go too much into it. And the reason is it's just like a really hard subgraph, and I'm just going to kind of show you how I would determine that. And basically, like, I have the compound protocol downloaded here, and I open up their contract repository, and they have, like, I don't know what it is. It's about 30 different Solidity files. And if you look at them all, we're not going to look at them, but, you know, there's a ton of Solidity here. It's really hard to determine what the protocol is doing. And so I actually wrote like this compound v2 subgraph, but it took me a long time because I had to understand the whole entire compound protocol, because you can't really write a subgraph unless you understand what all the data you're ingesting is, because otherwise it's likely to have errors. So like I had to make sure everything was perfect, and it took a lot of iterations, and it took, you know, maybe weeks for me to write it. So that's just one indication. Like if you look at compound's schema, it's actually not that big and it's kind of readable. So you might say, oh, it's like medium hard or medium. But once you look at the actual compound protocol, you realize you're going to have to understand what all this Solidity code and like smart contract code is. So then right there, it's kind of like, it's kind of clear that it's going to be a hard subgraph to write, but also very valuable because compound's a huge project. And so that's like when I'm evaluating subgraphs, I'm basically, my main two things I'm going to look at is like, first look at the Solidity code. If it's long and complex, I know the subgraph will probably also be complex. Look at the actual application itself and determine if it's, you know, if it's complex or if you think it's actually pretty simple like Uniswap. And then really focus in on the schema and read it, because it should be human readable. It should be able to, like, if the subgraph developer is doing their job, you should be able to read all these fields and really understand what they mean, as long as you understand the protocol from a high level. And those are really the two big indicators for me if you want to like determine what a good subgraph is, and like how complex it is and how valuable it is. And so just to like cap it off, you know, like I said, like one thing I think I really like to drive home that isn't maybe clear to like the community at large today is that, yeah, like there's not a single subgraph for compound. There's not a single subgraph for Uniswap. There can be many different subgraphs that look at the data in different ways. So you could be a subgraph developer or a curator, and you could look at, you know, this is maybe the most popular compound v2 subgraph, but you could make a completely new one, or somebody else could make a new one that looks at the data in a different way, and it could actually be better. And both of these subgraphs could live beside each other and both be queried. So that's something that I think will start to happen a lot more as more and more development and resources go to Web3, is we'll see like all this crossover of different subgraphs for like the same protocol. And one thing also is like a subgraph also doesn't have to be tied to one protocol. There's no reason you couldn't, you know, use the Uniswap subgraphs and a compound subgraph in one subgraph. We also have something called subgraph composability that's coming in the future, but that's kind of like a separate thing. What I'm talking about here is like, if you wanted to build a decentralized price oracle, you could use Uniswap's. Uniswap has an ability to be a price oracle, so you could use that. You could go get the price feeds that are released from Chainlink. You could get, there's definitely other protocols out there that also have price oracle like kind of endpoints that you can hit, mostly like decentralized exchanges, and you could kind of aggregate all of these to get one like total like decentralized kind of price oracle for, you know, ETH USD, and it would be more robust because it's not just based on a single protocol like Uniswap, right? So that's kind of like what I want to get across is there's a lot of different subgraphs that can be built. And so going forward, like when the graph network is actually launched, that's kind of the job of curators, you know, whether you're just a curator or a curator / like subgraph developer, it's kind of like everybody's job who wants to do that to figure out what the valuable data is going to be on chain. And like, you know, if you're able to develop that subgraph, you go make it yourself. And if it is valuable, like it will be rewarded because a lot of people will use it in the graph network. And, you know, if you're not a subgraph developer, but you're still a curator and you can recognize that, you should be watching for those types of subgraphs. And like, when you see them, definitely like, you know, signal towards it. And like that's the whole point of the graph protocol. Like these curators are meant to drive signal and like notifications on what subgraphs out there are going to be very valuable for the community at large. And so that's pretty much all I have to say. I'm just going to pass it off to Eva, and I think we'll do a Q&A or something.
Awesome. Thank you so much, Dave. That was so thorough. And if anyone, you know, wasn't able to keep up with that, we will have a recording to share afterwards. And phase 2 is all about you learning more. So we had a few questions, Yaniv and Dave. So the first one was about aggregation. And so if your goal is to do analytics, what's the trade-off between having the aggregation in the subgraph, like for Uniswap, versus doing the aggregation in the subgraph versus keeping it simple and aggregating client side? And then where is that calculation stored?
Sure, yeah. So today, all of the mapping logic runs at ingestion time. So you're pre-computing all of those aggregates and all of those values. And basically the trade-off is it's more expensive to compute ahead of time, but it makes querying that data a lot faster. So for a lot of things, I think that is the right trade-off. In the future, we are entertaining ways of doing query time kind of aggregations. But that hasn't been implemented yet. So, you know, that could be an improvement if there's data that is very kind of like optimistic, like very few people are going to want to query it, then maybe it is kind of, you know, wasteful to do all of that computation ahead of time. But generally our finding is that, you know, making sure that all of the data is already processed, organized, ready to go so that applications can query that data, you know, really quickly is actually a great kind of point in the trade-off space to make. And so that's how it works today. And I think that it's good for 95% of the use cases, and only if basically the subgraph that you want to build is intractable, you know, would I look to maybe, you know, doing things client side.
Awesome. Another question is, how long does it take for a subgraph to update? And maybe you can speak more to what the differences are in the length of time for different subgraphs.
Yeah, sure. I can take that one. It really depends on like the complexity of the subgraph and how much data is kind of being ingested. So like the fact that Uniswap gets used so much, I don't know how many transactions happen a day, but it's definitely like thousands, maybe tens of thousands. But that means that the subgraph is going to have to ingest all of that data. And so whenever you, and the thing is, like, we have to start from when, let's say Uniswap v2 launched, which was around like block 10 million. So as Uniswap keeps going and going and going, and we want to start a brand new Uniswap subgraph, you have to start from, you know, block 10 million, which might be 7 or 8 or 10 months ago. And you have to, you know, basically process all of that data. And so it's not, sometimes you really won't learn it until you build the subgraph and you actually launch it and you watch it start to sync, and it'll say like, okay, it syncs, and it syncs in 2 hours. Or you might watch it and sometimes it'll take like a day or two, right? And so then you have to determine like, why is it taking so long? Well, Uniswap's been around for 8 months. It's the most used protocol, and I'm tracking every single transaction. Then all of a sudden you might realize like you might want to split the subgraph into 2. You know, maybe one is for transactions and one is for analytic data. And the idea is just, you know, as a Subgraph developer, if you can kind of get a visualization of the protocol and how it's been used in the last year or 2 years on Ethereum, and then if you kind of get an idea of how many transactions have happened in that time, you should be able to get a rough estimate of how long it'll take.
Yeah, and so, that's, regarding the indexing time, how long it takes to index a subgraph, which, could take anywhere from minutes to days. Of course, that work is done ahead of time, and then once a subgraph is synced by an indexer, then querying it is really fast. But as far as how long it takes to update data, let's say that a transaction was included in a block, processing that block can take just tens or hundreds of milliseconds. So the data updates really quickly. That's going to depend on how much work any individual graph node is doing. So if a graph node is indexing, 1,000 subgraphs, it's processing a new block that touches, 100 different subgraphs. It's going to take it a little bit longer to process that block. And so, those are the types of optimizations that the indexers are making to decide, how many subgraphs should I be indexing on each node to make sure that I can process data efficiently, and they're kind of competing, based on price, performance, and security. And that's, a really nice part of kind of separating the curator roles from the indexer roles, is the curators can just be thinking about, what data do we want to expose, what's going to be useful to the community. It's very declarative. And then the indexers can figure out what are the right ways to optimize to make sure that that data is being processed quickly and is being served efficiently.
Awesome. So another quick question was, what would make a bad subgraph?
I think there's there's 3 measures that we look at for subgraphs. There's complexity, completeness, and accuracy. And all 3 of those are really important. If you have a subgraph that, has all of the fields that you could want, but the numbers that you get back are wrong, that's obviously really bad. You don't want that. So accuracy is like a must-have. Completeness, you could say, is like a nice to have. A subgraph that has more fields that are more useful for more applications, right? That would be more valuable than a subgraph that's like missing half of the data. So, I think that kind of a good minimum bar for a subgraph is you want to include like all of the raw data that's in the protocol that you're ingesting, because, if you're just like missing data for no reason, that's unfortunate. Then there's questions of, what additional views do you want to build on top of that? So different aggregations, different, insights that you can pull from that data. Those are nice to have. And the more of those additional insights and aggregations and computations you surface, that can make a subgraph more valuable. And then, the complexity, I guess that's just inherent in which protocols you end up indexing. So it shouldn't, really impact like a good subgraph versus a bad subgraph.
Cool. I think we have time for one last question. So someone had a question about incentives. They understand the incentives around curation and indexing, but what is the incentive for a subgraph developer? And if they independently develop a subgraph for a dApp that gets heavy usage, how are they incentivized for that?
Yeah, great question. So on the curator side, there is a natural incentive there. If you're the developer that built a subgraph, then you can be the first curator to signal on the subgraph. And since curation happens on a bonding curve, that means that you'll own more of those curation shares. So that's a great natural incentive there, just to be like the first curator. And then other than that, we're also going to be incentivizing subgraph development through like bounties. And I alluded to that earlier with the hackathons, but this is an area that we want to experiment with in the future, using things like quadratic funding to help make sure that there's always funds available for developers to build new subgraphs and to allow the community to allocate those resources efficiently.
I would also add that the implicit incentive for a subgraph developer, if you're also the one that built the protocol, is that subgraphs can actually make it a lot easier for applications to integrate. So if your objective is to get more, volume to your DeFi protocol, then you want a subgraph that makes it really easy for front-end developers to integrate. Awesome. If there aren't any more questions, I think this might be a good place to wrap it up. And we'll be sending more information about phase 2, what are the missions, and also sharing a recording either later today or tomorrow.
Great. Thanks, everyone.
Thank you.
Thank you.